Alrighty friends, this is going to be a quick video going over questions 5, 6, and 7 on that stoichiometry practice sheet that we worked on in class on Monday and on Tuesday. So we'll jump right in with number 5. This is asking how many grams of magnesium oxide are produced when 80 grams of magnesium is lit on fire, which we are told here means that it is reacting with oxygen. So I know that my reactants here are going to be magnesium and oxygen, because those are the things that are reacting. And we also know the product is going to be magnesium oxide. I know the formula for magnesium oxide is just MgO, because magnesium has a +2 charge and oxide also has a -2 charge. So those charges cancel out, just MgO. And then we also have to balance this chemical equation. I see 2 oxygens right here, so I need 2 oxygens on my product side as well. So now my oxygens are in balance, but in putting that 2 there, now I have 2 magnesiums as well, so I have to put a 2 there to finish balancing this chemical equation. So this goes 2, 1, 2. Now I can set up my BCA table and think about plugging stuff into it. Remember, my BCA table is good at keeping track of amounts of different chemicals during a chemical reaction, or before, during, and after a chemical reaction, actually. And so we can take this 80 grams of magnesium and decide that this is before the reaction happens. So I'm going to put that quantity right here. But the problem is that grams actually cannot go in our BCA table ever. Before putting anything in our BCA table, we have to convert into moles. So I'm going to look at my periodic table to tell me how to convert grams to moles. And my periodic table will tell me that I have to divide by the molar mass in order to get from grams to moles. So I'll punch in my calculator, I'll punch 80, divide by whatever the molar mass of magnesium is, and that number is 24.31 grams per mole. So that's what I'll punch in my calculator. 80 divided by 24.31, and I got 3.29. That is the number of moles of magnesium that is equal to 80 grams. So that number goes right here. And now that I have something in my BCA table, I can do the rest of it. All right, so remember, our next step when we have a BCA table like this is we're going to take the number the number of moles that I'm reacting, right? I'm going to use all 3.29 moles of my magnesium. In order to do that, how many times do I have to do this reaction? Well, when I do the reaction once, I use up 2 moles of magnesium. So I can just do 3.29 divided by 2 to realize that every time I do this reaction, I'm going to use up I have to do the reaction like 1.645 moles of times in order to spend all 3.29 moles of that magnesium. So again, I just divided 3.29 divided by 2. And now I'll take this 1.6 number, and I could distribute this to each of my other coefficients. This is telling me that I'm going to spend 1.645 moles of oxygen as I react this amount of magnesium. But really the number I care about is going to be the one that goes right here, since that's what the question is asking about. It's asking about magnesium oxide. So I'll go 1.645 times 2, and that gives me back my 3.29. That is the amount of magnesium oxide that I am making. And I'm almost done, But I noticed that in my question, it's asking me how many grams of magnesium oxide are produced rather than moles. So then I need to look at my periodic table to figure out how to convert moles to grams. And I can see that I have to multiply by the molar mass. So now I'll come find the molar mass of magnesium oxide. That's going to be a 24.31 like it was before, but to that I'm going to add a 16 for my oxygen. And now when I add these numbers up, 24.31 plus 16, I get a molar mass of 40.31 grams per mole. That is the number I'm going to multiply here by my 3.29. All right, and now I multiply these two numbers. My answer is 132.62 grams, and that is my final answer. So I would write 132.62 grams of magnesium oxide can be produced from 80 grams of magnesium. And there we go. That's all of 5. Question 6 is kind of similar. We have another synthesis reaction here. This time we have sodium metal combining with chlorine gas. I know that chlorine gas is Cl2 because that's one of my diatomic elements. And I know that the formula for sodium chloride is just NaCl. So I can balance this real quick. I can put a 2 right there and a 2 right here. This one actually balances exactly the same way as the previous question. So 2, 1, 2. And the steps are really similar as well. I'll go ahead and draw in my BCA table. And the first quantity that's going to go in my BCA table is this amount of sodium chloride, right? But once again, I cannot put grams in my BCA table. I have to convert that to moles. So in order to convert my 40.5 grams to moles, I have to divide by the molar mass. So I need to find the molar mass of sodium chloride. That's going to be 22.99 plus 35.45. Which gets me 58.44 grams per mole. That's my molar mass for sodium chloride. And so I'll take my 40.5 grams of it, divide by the molar mass, and this tells me that 40.5 grams is really 0.69 moles. And so that is the amount of sodium chloride that I am making, right? So I will put plus 0.69 moles right here. And now I got to ask myself, okay, in order to make that many moles of sodium chloride, how many times do I have to do this reaction? Well, I can figure that out by dividing 0.69 divided by 2. And that tells me how many times I'm going to do this reaction. I'm dividing by 2 because that's the coefficient of 2. You don't divide by 2 like every time. So 0.69 divided by 2 gets me 0.345. That is the number of moles of times I'm going to do this reaction. And in doing that, I'm going to end up spending 0.345 moles of sodium. And I'm sorry, that's not right. I'm going to end up spending 0.69 moles of sodium and also 0.345 moles of chlorine. The number I care about, though, is this one, right? Because I want to know how many grams of sodium metal are required in order to make this much sodium chloride. So next, I just need to take this 0.69 moles and convert to grams. The way I convert to grams, once again, is you multiply by the molar mass. So now I'm just going to take my 0.69 moles, multiply by the molar mass of sodium, right? And this will be 22.99. All right, so 0.69 times 22.99 gets me 15.86. And that is the number of grams of sodium that will be required in order to make 40.5 grams of sodium chloride. And I'm pausing here because that number does not sound familiar. Hold on, let me make sure I didn't make any mistakes. 40.5 divide by that molar mass. That makes sense. Divide by 2. Bring that here, multiply by 2, get it back. 69 times molar mass. Yeah, that seems right. I guess I'm just second guessing myself. But that's right, it's got to be 15.86 grams. Okay, cool. Last one I'm going to do number 7. So here we go. Iron 3 oxide is formed. So I know iron 3 oxide is my product this time. That's iron 3 oxide, by the way. I know that because iron has a +3 charge according to my Roman numerals. Oxide always has a -2. So I can just do this crisscross thing. Remember, where my irons add up to +6 and my oxides add up to -6. And that's how we get those to cancel out to 0 charge. All right, so that's iron 3 oxide from iron and oxygen gas, O2. And we need to balance this chemical equation. I'm going to throw a 3 right there and a 2 right there to make my oxygens balanced, and then I'll put a 4 right there, and now my irons are good. This balance is 4, 3, 2. Remember, on the quiz, if you have completely forgotten how to balance, or if maybe you never really got it in the first place, you don't have to be able to balance on this quiz unless you want a 4. If you're trying to get a 4, then you need to know how to balance. If you're just going for a 3, you don't need to know how to balance. All right, so 0.5 grams of iron, we're allowing that to completely oxidize. So I'm going to be starting with my 0.5 grams of iron before the reaction. But just like in all the other ones, I have to first convert my 0.5 grams to moles. So I'll divide by the molar mass of iron, which is 55.85 grams per mole. And when I do 0.5 divide by 55.85, I get 0.00895. So that's the number of moles that I'm starting with. I can put that right here, 0.00895 moles. I will divide that number by 4 this time. That gets me the number I'm going to, like how many times I'm doing this reaction. So this is going to be 0.00224. And that gets distributed all the way over to my 2 over here with my iron 3 oxide, because that's the substance that I'm interested in. So when I multiply that number by 2, I get that I am making 0.00448 moles of iron 3 oxide. All right. Last step, I have to convert to grams here because that's what it's asking for. I got my answer in moles, but I got to convert to grams, which means I'm going to use the molar mass of Fe2O3. So the molar mass for that is going to be 255.85s and 3/16 for my 3 oxygens. And this gets me 159.70 grams per mole. So to get from moles to grams, I multiply by my molar mass. So I'll multiply by 1.59.70 grams per mole. And this gets me my final answer of 0.715 grams of iron 3 oxide. And there's my final answer. Alrighty, so if you can do these 3 questions, or if you can do the other ones, you should be able to get a 4 on the second part of tomorrow's quiz. All right, I hope that was helpful. Good luck, have fun studying.